Now we're ready to take a look at some programming examples of recursion. For this movie, I have already created a template in my exercise folder under 0103 that can be used as a starting point. The main method has been set up to test 3 functions. The first one will print a list in reverse order, followed by finding the factorial of any natural number, and finally finding the greatest common divisor of any 2 numbers. Let's start with the task of printing a list in reverse order. We know we need to figure out what our base case is. So we'll set it up so that we print out the list in reverse order, and then when there's no items left, we'll print out the first item. So the idea here in the recursive function number 2 is to print the list except for the first item in reverse order. And what we do is we constantly shrink our list down so that we pull the first item out each time until the list is empty, and then we go ahead and print them, starting with the last one going to the first one. Let's take another look at a different visual. So here is our list. We have a list of numbers 10, 20, 30, 40, 50, and I have a function called reverse. When I pass those numbers to the function reverse, reverse then takes the first value out, the 10, and then it calls reverse again now with a smaller list, because now I need to reverse the numbers that are in the smaller list. So next I pass it the 20, 30, 40, 50, and this time I take out the 20, and I'm only left with 30, 40, 50 in my list. This continues, and you can see in this step I pulled out the 30, so now I have 30, 20, and 10, until finally, when we're all done, we print out 50, 40, 30, 20, which is the remainder of the list, and then we print out the first value that we got in the very beginning, which is 10, and our list is printed in reverse. We'll take a look at the code for that in a minute. Next, let's talk about factorial. Factorial is a classic example of a recursive procedure. To find the factorial of any number n, you would say that the factorial of n is n times n minus 1 times n minus 2 times n minus 3, all the way until the value of n minus some number is 1. So that tells us what our base case is. What is your base case? It's when the value gets to 1. We want to make sure we don't go to 0 because we all know if we multiply anything times 0, we're only going to get 0. An example of 5 factorial would be 5 times 4 times 3 times 2 times 1, which is 120. So we stop when we get to the 1. The base case returns a value without making any subsequent recursive calls. It does this for one or more special input values for which the function can be evaluated without recursion. Then the step that we use to reduce the process is the recursive function. The sequence of input values must converge to that base case. So in our case, we're reducing the number by 1 each time, so we're converging from 5 down to 1. In this example, to find the factorial of the number 5, we would say, okay, take the number 5 and multiply that times whatever the factorial is of the number 4. Well, before moving on, we then have to take 4 times the factorial of 3, and then 3 times the factorial of 2, and 2 times the factorial of 1. Once we get to this point, this is the recursive process, and at this point I haven't done any multiplication. I just keep calling the factorial function. Now, what happens is the very last case actually says, okay, I'm down to the number 1. So now I'm going to return what we see here, the 2, and then we're going to replace the call to the factorial function using the number 1 with a value of 1. Okay, now we go to the next step. Now we take 2 times 1, which is 2, and we plug that in for the step above it where it says factorial of 2. So 2 gets replaced. Now we do 3 times 2 is 6. And this process continues. Now we have 4 times 6 is 24. And finally, 5 times 24 is 120. So it's almost like the process goes down and then back up again. What's happening here is the values as it goes down are getting stored in a stack heap out in memory. So in memory we have 5 times something, 4 times something, 3 times something, and 2 times something. And then once we figure out we no longer are inside of our repetitive call to the method, then we start to plug in the numbers. We take the number off the heap, which was 2, 2 times 1. We take the next number off the heap, 3, 3 times 2. The next number, 4, 4 times 6, etc. And finally, the example I'm going to show you here is the greatest common divisor using Euclid's formula. So again, we need to have a base case. The base case for finding the GCD of any two numbers is when the remainder reaches 0. Then you know that there's no more divisors. And the repetitive case, or the recursive case, constantly finds the remainder of the two numbers. Okay, let's switch over to NetBeans and take a look at the code that we need for these three recursive examples. As I stated, in your exercise files folder, there is a recursion examples.java file. So you'll want to make sure that you create a project and you copy this file into your project so you can use it. At the very top, under public static void main, actually let me put my line numbers on so it's easier to refer to them. I'm going to go to View, and I'm going to say Show Line Numbers. There we go. All right, so on line 19 is where my main program is, and you can see on line 21 is the start of the process that will actually print a list in reverse order. Well, first I have to create a list, so that's not really part of the recursion. But on line 21 I have int, bracket, bracket, num list, and I assign it some values. Then I call the recursive function, which is called reverse print, and I give it the array list. Let's scroll down a little bit. It comes down to line 37, where it actually says, okay, here's reverse print, I'm going to expect an array list. So what I want to do here is I want to start out with my base case. Now we said when we were reversing the list, the base case was when there were no more numbers to be reversed. So I'm going to say if numbers.length, since that will give me the length of my array, if that's equal to 0, equals 0, then I'm just going to return. If that's not equal to 0, I want to call reverse print again, but this time I want to do it without the first element, because I want to take the first element out and then reverse the rest of the list. So to do that, I have to actually create a new array. So int, I'm just going to call it a, is equal to a new int array. And this one is going to use numbers.length, but it has to be one less than the length of my original array, because don't forget I'm taking that first value out to be printed. Okay, now I want to copy the values from numbers into a. So I'm going to say for int I equals 0, as long as I is less than numbers.length, semicolon, length, but I only want to go to length minus 1, right? Because I don't want to go all the way to the end, and I'm going to do I plus plus. And now what I'm going to do is I'm going to say that the new array, a sub I, is equal to, and I'm going to start at position I plus 1. So that way I'll skip over the very first element, and I'll move the rest of the elements into my new array. Okay, so now what I need to do is I need to call reverse print with this new array. So here's where the recursive part happens. I call myself reverse print, which is the name of my method, and I pass it this new array, which has all the numbers except for the very first element. And then below that, I'm going to add a system.out.println, and I'm going to print out the value in the numbers array starting at position 0. That lets me print out each of the elements as they appear in reverse order. So what's going to happen is the reverse print is going to constantly call itself until it gets down to there's no more items. When there's no more items, then what's going to happen is it's going to go back through all the items in the array, and it's going to print them out one at a time until it gets back to the first item. All right, let's save this and let's run it. And we can see if I move my window up a little bit, my output window, that it did print them out in reverse order, 50, 40, 30, 20, and 10. So it looks like that did work. Let me close this. I'm going to change this just a little bit to actually, instead of doing a print line, just to do a print. And I'm going to run it again. And the reason I have an error, I'm going to say run anyway, is because we haven't finished the factorial or the greatest common divisor yet. I wanted to show you how the reverse print works first. All right, next, let's move on to factorial. So I'm going to scroll back up here, and you can see I have the call in the main method. If I highlight these and I click on this button here, it says to uncomment. Now my factorial call is also active. So let me scroll down to factorial, and let's add that code. This is actually going to be fairly simple. Remember, what is our base case for factorial? The base case is when b is equal to 1. That means that I've gone down to the very last number. If that's the case, I'm going to return the number 1. If that's not the case, then I want to take the value of b times the factorial of b minus 1. Remember, your numbers have to converge to some kind of base case, so you have to have that b minus 1 there on line 53 so that my number, if I'm using factorial of 5, when it gets down to 4, 3, 2, 1, then it will stop. If I just put factorial of b, I'd be in this nice little infinite process and it would never end. All right, let's run this. We'll first see the reverse print list, but then we'll also see the factorial. Okay, it says enter a number. Let's enter 5, and we see the factorial is 120. All right, that seems to be working, and the last one is the greatest common divisor. So again, I'll scroll up to my main function, and I'm going to uncomment the code here by clicking on this button. And now I'm going to scroll down, and I'm going to add the code for GCD. There is one little mini task I want to do because I need the numbers to be the largest first and then the smallest, so I'm going to check to make sure that's the case. I'm going to start by declaring a variable temp, and I'm going to set it equal to a. Then I need to know if a is less than b. Since I really want it to be the other way around, I'll switch them. And if it is, then I want to say that a is equal to b, and then I'm going to say that b is equal to temp. So now a and b are swapped. Okay, if you're not familiar with how to swap two numbers, then take a closer look at this, but that will work. And the next thing I want to do, so now that's just getting the values coming in the right order. So now let's do our base case. We said earlier our base case was when the remainder, which is represented by b, is equal to 0. So if b is equal to 0, I'm just going to return a as my GCD. Otherwise, I'm going to return the call to the greatest function again. Here's my recursive call, and I want to give it b along with a % b, which means find the remainder of a divided by b. So then it comes back through, it'll check and see if there's still anything to divide. If there is, it'll keep going until it finds the greatest common divisor of the two numbers. All right, let's run this. Let's enter in a different factorial. Let's try 7 this time. We get 50, 40. Now let's enter two numbers for our GCD. Let's start with two numbers that we know are divisible. So let's do 26 and 13. We get 13. Let's run it again. I'm going to put a 5 in for factorial. Let's enter two prime numbers and see what it does. So let's do 13 and 37. Well, you know that the greatest common divisor of two prime numbers is just 1. So it looks like everything is working. Everything seems to be performing pretty quickly. Sometimes the only benefit to using a recursive process is to reduce the amount of code, which might be the case in the factorial problem here, which is actually a very short amount of code.